Last time I figured out that this was my local capture shortcut that uh, was interfering with the shortcuts of the Visual Studio, so everything was screwed up with my local. And we said that when we say a cat is an animal, when there is this is, by the way, quiz will have some of this type of questions, so let's just be careful. When we say something is something, a cat is an animal, that means this cat will inherit whatever animal has and will have access to all its public and protected parts. Protected is what? We don't know yet. I will explain that. But when we say a cat has something, it means this has is a member variable for that cat or a member function for that. So we shouldn't mix these two things. A cat is something, is inheritance basically. A cat has something, it is, we are referring to cats' member variables and member functions. And this is not reversible. You cannot say animal is a cat. Animal is not a cat. Animal can be anything. So it is not reversible. So whatever cat has, animal doesn't. This is the waterfall of the hierarchy is a one-way direction, starting from the base class or the parent class toward all the children that are all being derived one from another. So, in the concept questions, you should be careful about this is and has and what inherits from what. Uh, then, if we take a look at animal, in the animal we had, apart from this member function, its name, we had uh, a default constructor. We had a query to get name, a setter for setting the name, and we had three member functions, act, move, and sound, that we simply printed a message uh, to distinguish who is doing this act. Why? Because we said that we can have the same member function for a child, and we said that this is overriding a function. This was not overloading. There was a big difference between overloading a function and overriding a function. In overriding a function, we have, which can only happen when we have a base and its children classes, basically. They can have the exact same function with the exact same name plus exact same input arguments. Uh, and we said that this is overriding. Overloading was having same name of functions but with different input arguments, right? We should distinguish these two. Now, we are basically talking about a new concept, and that's overriding a function. So that's why we are printing these messages with name animal in all of them, so that we know when we are instantiating an object and calling one of its member functions, we want to know exactly which function is being called. Why? Because now we have exact same functions for the base class and the cat class. For instance, in animal we have act, move, and sound, and in cat we have act, sound, and play. So two of the functions are the exact same function, common functions. Animal has act, and sound, cat also has act and sound, the exact same functions. Cat doesn't have move, animal has move, and but cat has play. Now, can somebody tell me, now that we know cat inherits from animal, and now that we know cat can play and animal can move, can cat move? Can cat move? Yes or no? Yeah, yeah, go ahead, please. Armando, go ahead, please. Yeah, the question is, now that we said that animal can move, animal has a member function called move, and cat has a member function called, like, has all these functions. It doesn't have the move. Can animal move or not? And we know that cat is a child class of parent animal class. So the question is, can cat move? If I can I write cat dot move, and will this be okay, or will I get compiler error? Okay, good. Yeah, many people said yes, and that's exactly the concept of inheritance. Even though I am not repeating move function in cat, but since cat inherits whatever animal has, the cat also inherits the member function move that its parent had, but it doesn't. Now, another question. If I instantiate an animal, okay, create an animal, if I instantiate an object type animal, will that animal be able to play? Yes or no? Good, great. Okay, I think I'm convinced you guys really know the meaning of inheritance. That's exactly true. The answer is no. Why? Because we said that inheritance is a one-way highway. Animal cannot and does not have the things that cat has. Parents cannot have the things that only their child have. Very good. So now we know the animal thingy, the concept, and the cat thingy, and the inheritance, and uh, some of these things. Now, we said that last week we also saw this, that an object of type of the child type. For instance, here the object of type cat, we have a Percy with 3 number of lives as a cat, and we have Dixie with 7 number of lives as a cat, and we are referring to these cats with two different pointers. The first one is a cat pointer. The second one, Dixie, is being pointed at with an animal pointer. We saw there that when an object is being referred to with its parent pointer or reference, it will completely completely forget that it is a child, and it will have only access, and it will have only the belongings of its parent. So literally here, even though cat will be created, but it will not be a cat. It will not be able to act or move or sound like a cat. Why? Because we said that we are storing this in a container of its parent type. And we gave an example. We said that now, consider we constructing a building. The first floor, or the base floor, not the first floor. The base floor is animal, and the first floor is cat. When we are creating a cat, that means you are creating the first floor. In the time of creation of the first floor, you cannot create the first floor on the space. You have to first build the first floor. So anytime I'm saying new cat, blah blah, I want this to be created, or I want this to be created, two things are being created by the compiler automatically at the same time, no matter what type of container you put this. Now I will run and we will see. Whenever we are creating the first floor, the compiler goes and creates the base floor first, and then creates the first floor, puts it on top of that. Now we will see this. Now we will, when I run, this will, the compiler will first create the animal, and animal will say, the constructor of the animal will say that, do we have a message here? No. The constructor of the animal will say that creating this animal, the animal, and the constructor of the cat will say creating this, the cat. And we will see both. Let me run. See, what we did is, forget about this container thingy now, for now. What I'm saying is, cat, regardless of what kind of container you have to keep in, will be created on top of its parent. So there is no way to create cat as the first floor in space without having the base. These are these two lines that you see, creating Percy the animal, creating Percy the cat, and then creating Dixie the animal, creating Dixie the cat. This is automatically happening by the compiler. I am just creating a child. I'm basically instantiating, dynamically instantiating a, an object of type child, which in this case is cat. And my compiler goes and automatically creates first an object of type animal, and then an object of type cat. Are we good so far? Does this make sense? Okay. Now, the second story, the second thing that comes in is that now that we have these cats, if I keep them inside a cat pointer, a pointer of type cat, I'm good. I will have access to all the possibilities and all the things that this cat had. So I'm gonna say CP act. CP now is Percy. So Percy will act like a cat, will move like a cat, will play like a cat, and will sound like a cat, because it is a cat. World is good, life is good, everything is good, no problem with that. Let's see the output now. See, Percy Now this is the output. Percy had 3 lives. This is lives, by the way, not lives. Percy acts like a cat, moves like an animal, plays like a cat, sounds like an animal. Percy sounds Mia. There are 2 animals here. One of them I have put here. It is in the sound of cat. So let's go to the sound of cat. And in the sound of cat, I have put this. I wanted to when a cat I wanted when a cat sounds, I wanted this to sound first like an animal. So this was intentional. The second animal here, the second animal here is intentional. This is exactly the result of this. It first calls its animal sound and then goes to the next line and prints this message. But here, Percy was a cat. We created that as a cat and we kept that. We kept that in the animal pointer. But when it came to move, it was able to move, but it didn't have any move by itself, right? That's what we discussed. Since it didn't have any move by itself, it still was able to move, but what kind of move? Its parent type of move. It moved like an animal because it didn't have its own uh, its own member function called move. It moved, and life is very interesting. Life is getting very interesting now. We don't have any problem with this, I guess. If so, anytime, just unmute and ask. Now, the problem, let's see if there is a problem or something here. Another thing that we did was we created an animal pointer and we kept that cat in that animal pointer. So imagine, it's actually not possible, but imagine you could squeeze or reshape or eliminate the first floor of a building and put that in the base floor. That's what exactly we are doing. So in this case, we lose access to being cat anymore. When we are when AP animal pointer, which is Dixie, wants to act, this time it will completely forget that it is a cat. We created that as a cat, but because we put that in a parent pointer type, it completely forgot that it's a cat, and it acts like an animal, moves like an animal, and sounds like an animal. Let's see. Now, when it comes to Dixie's name, Dixie acts like an animal, moves and sounds like an animal. Everything is like an animal. Why? Just because we put that in an animal pointer, which is fine. So far is fine. At least there is no technical issue, no problem. All right, no problem. If I refer to a child with its parent's pointer or reference, it will forget that it's a child. It will act completely like its parent. Totally fine, no problem. That's good. Now, the real problem, we said that, was here. Uh, in the basically this line. Can anybody tell me if there is any problem with this line? I mean, literally real problem with this line. And if so, if you say no, okay, is there a problem or not? Line 25. Is there any problem with line 25 or not? What is line 25 doing? It is simply deallocating the memory that was allocated for this animal pointer up there. I'm just I asked for some memory here, and now I'm deallocating that. Is this a problem or not? Keep answering, people, please. Now we have more yeses than no. We have more yeses than no. Okay, I'm gonna ask one of the yes people. Kathleen. Kathleen, you said yes. What is the problem with line 25? Are you here, Kathleen? Yeah. What do you think is the problem with line 25?
I think it could lead to memory leak because
Yeah.
it's a cat
Exactly.
it's an animal.
That's exactly the problem. That's exactly the problem when you are storing a child. Thank you so much, Kathleen. That's exactly the problem. Um, we are fine until we want to deallocate the memory that was allocated to that. Remember, and we can run and see again. Remember, we saw in the creation part, we saw that for cat to be created, every time an animal has to be created, and then a cat created on top of that. But here, when I am deleting animal pointer, it is the compiler and the order that the compiler is going to send to my operating system to deallocate the memory that was allocated is of the type animal pointer. It has the size of animal pointer. It has all the content types of animal pointer. So what we are facing here is we are basically losing our access to this cat part that was dynamically created at the time of creation. And because it was dynamic, our compiler asked our operating system to make some space available so that I can put this cat there. And it did put that cat there. So now the information Percy the cat, no, sorry, Dixie the cat, Dixie the cat is created here, but it is not deleted here. That is a problem. That is a memory leak. And we said that there was no way to fix this memory leak unless we know some new technique that we're discussing today. Um, that technique basically that takes us to the next step. But before that, I just wanted to repeat another term that you need to know, which is shadowing. We said that now we are overriding a function in the child, and that overridden function basically shadows its parent's function. So when you call a child, this is the child's member function that comes to play. I forgot that, and I just wanted to uh, repeat that again. Okay, so we faced the memory leak problem because we lost our access because we stored a child in a pointer of its parent type. How can we solve this problem? I'm gonna close this. Are we good with all these parts so far? If not, please unmute and ask your question. Uh, if we are good now, I'm gonna show you this code. Where is it? Okay, it is. Put everything in temp. Put in temp. Uh, we'll talk about protected thing after this. Now, the solution for that is to make your member functions as well as your destructor virtual. So what does this virtual thing do? This virtual thing basically pushes forward the call to the functions. How? This is how. When I am here again, when I am storing a cat in the animal pointer, we lose access to its cat capabilities. For instance, play. Fair enough. But what if I create a possibility so that this animal, whenever wants to call its function, look at its member function and see if there is this word virtual beside that, ignores this, and goes and looks for the same function in its in its created child classes. So this virtual simply means, Mr. Compiler, when anything, when any of these, for instance, act, when act of this animal is called, come check virtual. If virtual is there, you are not allowed to use this. You have to go one step further, see if there is any act in its child, which there is, and you are supposed to use this instead of animal. Same for all these move, sound, and the destructor. What happens to the move when here? Uh, if I want to basically uncomment these, let's keep these commented. When I uncomment these here, for the act, for the animal pointer acted like an animal in the previous example. But here, this will come here. See, we'll see that virtual is there. We'll go one step ahead. We'll look at the cat. We'll start searching for that function. If that function exists, it will call that function, even though here, uh, here, Dixie is an animal. But because of this virtual function, when we call act, it will act like its child. It's an animal, but it will act like its child. For move, what will happen for move? If I say move, it will come here. We'll see animals move is virtual, so it's not allowed to use it. The compiler will go to the child. We'll look for move. Is there any move here? No. Then, okay, permission granted. The compiler can use animals move because there was no update of this move in the child. What will happen to the sound? Same thing. It will come to the sound of animal here, line 27, will come to the sound of an animal. It will see that it's virtual, will find the sound of a cat, and will call the sound of a cat. For the destructor, it is exactly the same. And this is probably the most important part and take-home message of this lecture so far, that because here in deleting the animal pointer Dixie, it will come and check the destructor of animal because this is an animal pointer, and we will see that this destructor is virtual. So it will go look for the structure of its children, which is cat. And here, the destructor of the cat will be basically will come into play, will work, and we will be able to see the created Dixie as animal and the created Dixie as cat will both be deallocated. Uh, and of course, we didn't have any problem for line 30 because it was already cat pointer and cat. It was a cat stored in a cat pointer. So whenever I want to deallocate, it automatically goes to the cat and just deallocates it. Fine, there's no problem. But here with virtuality, we solve the problem. Why don't I put virtual to these classes of cat? I can. If I think somebody will derive another class from this, say kitten, for instance. If there is going to be a kitten in the future derived from cat class, obviously you for the destructor it's a must, but for others, if you want this uh, forward calling happen, or dynamic dispatch based on the notes, dynamically dispatches the call and pushes forward the call to the same member function that a child has. You can make also these virtual. Here, I'm not deriving anything from cat, so I'm fine. It's important to notice that this virtuality or this virtual keyword is only in the header file. You don't put that to the definition. See, definition doesn't change. All the definition, sound, move, everything is the same, and this virtual only goes to the header file. And now, if I run this, hopefully by tomorrow. Now, if I run this, let's take a look. So this is the same for each one of those, animal and cat, both created at the time of creation for both Dixie and Percy. Um, Here it was cat pointer, fine, but the main change has happened here. Because of this virtual thing, now, even though uh, we kept the child in in its parent pointer, but when it acts like a cat now. When it moves, it still moves like an animal because even though move is virtual, but there is no move in the cat. So the compiler checks that, but again comes back here because there was no move in the cat to be called. And then for the sound, it also has mu. It didn't have mu. It was all animal type, but now it also has mu because for the sound that happens. And most importantly, when we are deleting this animal pointer, because of this virtuality, we see that deleting Dixie, the cat, also happens. It's not just deleting the animal. So this virtual is necessary from now on for any implementation of yours that you are deriving one class from another. You have to, your base classes, although until the very last child that is being derived doesn't need this virtual. Other than that, all the destructors of in all the classes that are in this inheritance pathway should have virtual, so that whenever I am referring to any of these child classes with their parent pointer or reference is fine, parent pointer, uh, I make sure the last one will get called, and the last one will destroy everything. And if I want to show you, now you consider this, Dixie the cat is now deallocated, Dixie the animal deallocated, but if we take this out, make it same as it was in the previous version, we will see that this will be, come on please, we will see that it didn't happen. So we were safe for the memory deallocation here, thanks to this virtual capability of uh, C++ that we have. Um, so um, these are virtual member functions. And this is how you implement those. And one of the rules, maybe you should consider this rule of destruction. Rule of destruction is destructor of a base class or any class that you think inheritance or any other class will be derived from that must be virtual from now on, unless otherwise stated in the exam or workshop or whatever task that you are doing. But if nobody says anything, you put virtual to the destructor of the base classes. Does this whole thing so far make sense? Okay, very good. We had another, we talked about something else. And by the way, I have comments here that if you sometime if you review this code, you can easily understand the purpose of this code and what was basically new here. And another thing that I would like you to know is this is this is the concept of protected instead of public members or member functions. What is this concept? If you come to animal, previously this animal was a public member function of this animal. And as a result, I could simply use this in public. It's my main, it's public, and I could simply go ahead and say, I want, let me build this. See, I got an error in the build that says the basically this protected member get name is not accessible anymore. It was accessible in the past and it will still be accessible if I cut it from the protected part and put it in the public part. Now there will be no problem and I can build this without error. See, build successful. What is this? What does it look like in real life? Let me give you an example. I'm taking back it there because we have some more work with this to do. In real life, it is as if you have something, you as a parent, have something at home, and you don't want your neighbor or some stranger have access to. So you put in a place and you give access to your children. You say, okay, like, um, I know we have this thingy here, whatever it is. Only my children can have access to it, but not any other stranger or any other neighbor. That here reflects like this. If I put some member function as protected, that member function can only be accessed from inside its children's modules. So now get name of this animal is protected. So only cat and inside its module can access to that. So take a look at this. So we have this error. There is no way I can use my cat pointers get name query here because now it became protected. All right. What I can do, what I have done here is basically I have added another query to my cat. Said, okay, I know that this became protected, and the only person that can have access to this is its child, which is cat. Okay, so if I want to access this in public, I can add a query to this cat looking for what I was I used to be able to use, which is name, which was the property of animal. And by this in the implementation, now it's in, just add the signature to the header, and in the implementation I simply go there and say, okay, now if somebody called send name, Mr. Send name, use animals get name and return it, which is totally okay, which is totally possible. Why? Because now this protected function get name, this protected function get name is being accessed from inside its child's module. It's basically being accessed by its child, and it makes it totally possible. And instead of this cp get name, now I can use cp send name, and it will do the same thing. It will send a cp is Percy. So now I will see the Percy's name being outputted to me, Percy here. So we created this Percy, Percy the animal, Percy the cat, and we were with this trick, even though animal didn't give access to its query in public, but I asked its child to add a new query for me, and inside its query, go ahead and call its parent query and give me the name that I was looking for. And this is the meaning of protected. So we have private, we have public, and we have protected. And we obviously know the meaning of public and private, and this is the meaning of protected. Now, if I created another child, kitten, say from cat, derived from cat, that could also access animals get name function, and that could also use that. So children can access to the protected parts, but not anything else in the main, or in other words, in public. Uh, Give me feedback. Does this make sense? Okay, Wonderful, wonderful, very good. Now, this takes us to another concept, another practice that we have, and that is pure virtual. Now we know what virtual is, and I want to know what pure virtual is, and basically how is it different from virtual. In animal, now it's the same animal, everything is the same except for the sound. Imagine you don't know how an animal sounds. And in fact, we don't know how an animal sounds unless we know what animal we are talking about. So why bother? Why in real life? Let's make it even more similar to real. In real life, if I say, what is the sound of an animal? Nobody can answer that unless I say, okay, I want the sound of a tiger or an elephant or whatever. Then, yeah, it makes sense. So, there should be a way, there must be a way to implement that in C++ as well. And this is how we implement this. In the header file, we go ahead and put equal to 0. You remember we had, if we wanted the user not to be able to call, for instance, a copy constructor or whatever, we used to put delete here. I know you have seen this. So this way it means nobody can call sound, right? I'm making it inaccessible. It's similar to that, but instead of delete, you put 0 there. And by putting 0 there, we tell the compiler that, compiler, dear compiler, I don't have any implementation for sound in my animal.cpp file. That's why I have commented out this sound. And so, what? Now, why do we even do this? This is basically useful in two ways. Uh, you are creating a class, and you know that a child class will be derived from this class, and you know that something should be implemented there. You know that if somebody wants to create a some type of animal, you know that that animal should have a sound. The only thing that you don't know is in the level of its parent, you don't know what to put, or you don't have anything to put in the implementation. So you are postponing this implementation to the child when it is created. This has two side effects. First side effect, this cannot be uh, this cannot be called or instantiated or done anymore. This is pure virtual. Pure virtual is a virtual member function that doesn't have any implementation. There's nothing there. It's just a signature with equal to 0. And another side effect is that if somebody wants to derive a class from animal, it must implement sound. So this becomes a must. Anything else here is optional. But because my parent class has a pure virtual function, anyone that wants to create this child class must uh, must implement sound. Otherwise, it will face an error. Here, uh, here in the main. What I have done in the main is I have, so some parts are the same. Again, we have Dixie and Percy. What we have for the animal pointer sound here, now this line is important. Pay attention to this line. Uh, this line comes to the sound of an animal and realizes that nothing is there. When nothing is there, it means it should look for some implementation in the higher level, in the child level that it has. If it goes to the cat and sees there is no sound implemented here, this will be an error. If it comes here, I made sound a pure virtual uh, member function, and in the cat I commented this out. Let's see what happens. So literally there's no sound, there's no implementation. Sorry, there is sound. This in the signature there is, but in the implementation there is no sound. There is no implemented sound, and it is. See, we received an error. What is the error? The error is member function not declared in. Well, actually, let's do this in also in cat cpp. In cat cpp, it actually doesn't matter. It works both ways, but I just want to show that the error that we will receive is not that we have something implemented, but we don't have its signature. Now I commented out sound from the cat and commented out its implementation from the CPP, and let's see what happens. Again, error. What is the error? The error is now cannot instantiate abstract class. Oh, abstract class. So the new word that we wanted. What is an abstract class? An abstract class is a class that has at least one pure virtual function like this. So it comes to when it comes and checks sound. It sees in the animal here in the time of instantiation here when it wants to create the cat, as in a totality of the cat, the compiler is responsible for creating its everything, its member functions and its member variables and the implementation of everything. It come at this time it wants to create the cat, but it comes to the animal, sees okay, now animal sound is pure virtual, so I have no idea about its implementation. It goes to the cat, it doesn't find the sound there either, so there's no way to create this. That's why abstract classes like animal that that have at least one pure virtual function cannot be instantiated unless that member function is implemented in the child somehow. So I commented this out, and here let's also comment out these animal sound see out, return, and do this. Now in the main function, uh, hopefully I'm gonna see that uh, both cats will be created and will be initialized to Dixie 7 and Percy 3. And also, these will work fine, hopefully. And what will also work here is animal pointer sound will also work. It will take the sound of the child, which is cat. Let's see that. Okay, so we didn't receive an error. What happened is Dixie and Percy are created successfully. Um, we didn't have problem with this. Didn't have problem with this. What we were interested in was this sound. Sounds meow. Only meow. Something is missing. Do you remember? Can somebody tell me the difference between the sound that previously these cats made and this one? There is something different. Can somebody tell me what that difference is? There is a difference between the sound that this time Dixie made and the sound that Dixie used to make in previous files that I should in previous classes that I showed. Exactly, that's true. Hashmi, thank you. It used to sound like an animal, but it cannot now because there is no implementation of animal sound anymore. Why? Because we intentionally made that sound in animal. We intentionally made that sound pure virtual function with without any implementation, and as a result, it cannot it cannot call. There is nothing in animal as a sound that can be called there. Great, Hashmit, thank you. Okay, so let's review what we saw with what we learned so far. Let's review. Uh, we talked about inheritance being a one way, and whatever is whatever basically inherits that thing. Uh, if if a Honda is a car, Honda inherits whatever a car has, not the other way around. It seems obvious in real life when we are giving real life examples, but when it comes to programming, sometimes it becomes confusing and not that obvious. The second thing we learned was um, when we call a a child with its parents' names, those children completely forget that they are children and they act like their parents. The example was when we were referring to a child with its with a pointer of its parent type, and we saw that there is this danger that memory leak can happen. For that, we said, okay, I'm gonna put virtual for the destructor and any other member function of my base class that I want to be skipped and basically updated to the same member function of the child. I just put virtual there and compiler comes. If it sees there's this word virtual, it skips that, goes one level above, looks for the same function in the child, and if it finds, calls that. If it doesn't find, no problem. It comes back to the function that parent had. Another thing we talked about was the protected thingy. protected member functions were no longer be accessible in the main, and they were only accessible in their child child class modules, inside the child class modules, not in public, not in main. And uh, and then we reach today pure virtual functions. Pure virtual functions, we put a zero equal to zero in the header file, and we didn't implement anything for these function in the CPP file. These are called pure functions because we literally don't know what to put there, and we have to wait for the child to be created. We said that that requires the implementation of a child to definitely, for sure, definitely, it's a must to have to implement the function that is pure virtual in its base class. So for the cat, it was a must to implement sound. Why? Because sound was a pure virtual class in its parent class, animal class. And without that, we received error. We received compile time error that even that object of that type cannot be instantiated. And in the error, it said cannot cannot initialize uh, class of type abstract, and that was a hint to know what an abstract class is. An abstract class has at least one pure virtual function without any implementation. That becomes an abstract class, and that abstract object of that type cannot be instantiated. If not, can somebody tell me why I have why I have a constructor for this if it's not going to be if I'm not going to be able to create it and initialize it, uh, why do I have a constructor here? What good does it make? What do you think? Please think and then unmute yourself and answer this question. Tell me if that constructor is redundant. I don't even need that, or like it is there for a reason. What do you think? Okay, unless I'm gonna instantiate a pod. The question uh, is this constructor necessary here, considering that this animal is an abstract class because it has one pure virtual member function, and we can never instantiate it. Is this necessary here or not? Yes or no? Yes means it is necessary. No means it's not. Meanwhile, you're thinking, I'm gonna say animal, and I'm gonna add include include animal dot header here, and I'm gonna say animal A, and I will immediately receive an error. What I add is I'm I'm instantiating an object named A, type animal, and I'm receiving this error message. It says is not this is not allowed because animal sound is a pure virtual basically we cannot create because this is an abstract class. So how come uh, I have an I have here a constructor if I cannot use it at all? So now if I say animal dog, I want to show it this is still a problem. It will still show me the same error. Literally we were able to use this before. This is this is the here this line basically calls this constructor, and we used to be able to do this, but now we are not able to do that because this class has one pure virtual function, right? So how come I have that there? Let's see. People said yes and no, and some people didn't say anything. So from those yes people, let me see who has not talked yet, so far. Tran, you said yes, it's necessary. Why do you think it's necessary? Okay. Yeah. The second part of your discussion, I totally agree with that. Remember, well, actually, this is the part we didn't probably talk. We talked. This was one of the very important parts, and in your workshop also, this is an important part. We said that when I am creating when I am creating a child class here, cat. This cat has its constructor, right? Similar to other classes, it has its constructor, and in that constructor, I want to be able, I want to be able to not only set its member variables. What is the member variable of cat? Is number of lives. Not only I want to be able to initialize the member variables of my child class at the time of construction. I'm initializing that, but also I want to be able to initialize the parts, the member variables that are being transferred to it from its parent, and that was the name, right? Its parent had a name. Its parent had a name. Even though I will never be able to instantiate an object of type animal, because animal is an abstract class, because it has one or more, doesn't matter, one is enough. If it has only one pure virtual function in it, it's an abstract class. You cannot initialize it. Even though I cannot do that because of this, but in the child that I want to make, I want to be able to initialize its parent parts, which is the name. So I want to be able to, we said that this area from this braces, from this brace, until the opening curly bracket that I want to go ahead and implement my constructor, my child class constructor. I want to also be able to pass uh, the parameters to the constructor of my parent, so that that constructor can go ahead and initialize its member variables. I wouldn't be able to do that if I didn't have this animal constructor here. Remember, whenever uh, a class, an abstract class, of course, has a member variable, you should have a constructor to be able to use it later when you are creating a child, to be able to use it in the initialization area of the of your child's constructor. And you know that students let me, uh, and you know that you will never be able to initialize a pure abstract a sorry, let me just close on from here. Let's quit for now. I will never be able to initialize uh, create and instantiate an object and initialize if it is of type abstract class. But if it didn't have, if the animal here didn't have m name, it could be okay. You didn't even need an instructor, a constructor. How about destructor? Is having a destructor necessary? Let me see. I think this. First, let me know if you understood. You completely got the idea of having a um, constructor abstract for abstract class. Now, do we know why we have a constructor for an abstract class that we know we will never be able to use as it is? We will never be able to instantiate any object of that type. Manjo, Heejong, Arbaz, Alfej. Now, Heejong, Arbaz, and Alfej. I don't know your answers. I hope you're also yes like others. Very good. How about the destructor? Is having a destructor necessary? Now that we know, again, we will not be able to instantiate anything. So there's no, if there was no member variable here, I could freely get rid of this. Eliminate this, no problem. Life is good, everything is good. If it didn't have a member variable. How about the constructor? Do I need to have, in is having, the question is having a destructor a necessary thing, a must in abstract classes or not? Yes or no? We're getting some yeses. Okay. Everyone said yes except for one person. The answer is yes, it is necessary. If you don't have a destructor, how are you going to put the virtuality thing that we just talked about? We know that it's actually very, 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 very must, because you know that this abstract class is for no good except for deriving a class from it, right? I'm putting it there so that somebody comes and derives it. It cannot be used as it is. It's like it's a car, but it doesn't have an engine. So if somebody wants to come and write this, they should first build an engine and put an engine in it. But what is it good for? It's at least a car. The concept is known, and I can give it to somebody, say, okay, see, it's a car. It has everything. You can use it. except for it doesn't have an engine. Please put an engine, or like not an engine, a tire, for instance, or whatever, right? So it should have a definitely should have a destructor so that you can put a virtual destructor there, virtuality. You can add virtuality to that destructor so that whenever that child that is derived from this uh, is being pointed by a parent pointer, this virtuality can come and play and call the destructor of the child class. Okay, time is up, and I'm gonna give you guys a break. I'm gonna upload these as usual to our Git. You still have 5 minutes until the quiz starts. I'm here. If you have any questions, please ask. Otherwise, it's a break, and you don't have to stay here.
So after the quiz, can I have a separate call with you on team because I want your help with the milestone one. I have some questions about my code.
Sure. Send, yeah, it's possible, but send me your code because I will not be available immediately.
Yes.
Send me your code and I'll take a look at it.
Okay. Thank you, sir.
Okay?
I will send you that.
Yeah, thank you.
Thank you, Professor.
Thanks, Armando.
Professor, again.
Yeah, I'm here.
Professor, like if you wanna inherit constructor from the base class, then we're gonna use using keyword, right? In draft class. If you want to
Hmm?
inherit constructor from the base class.
Sorry, I didn't get your question. Could you repeat?
Like if you want to inherit um, constructor from the base class to the draft class,
Uh-huh.
then we're gonna use using keyword, right?
It's if you want to, if anytime you want to use the constructor of the base class in
Mm-hmm.
your child's class, this is how you do it. This is how you do it in the constructor of your child.
Professor,
Uh,
your screen is not shared.
oh, sorry. Yeah. Okay. In the This is how you do it in the constructor of the child class. Okay. You put the you put in this area, in this somewhere in this area, you put the constructor of the base class and
Yes.
pass the value that you want it to be passed, right? Here it gets the constructor of the cat gets the name and gets number of lives, but it doesn't have directly access to name because name is coming from its animal part. So you pass it here to the animal, and this is not calling a constructor. Last week we discussed this completely. This was not calling because you're not allowed to call a constructor, but this is called basically passing the parameters to the constructor of the base class, and that takes care of this for you. And this one is also another initialization. Again, like number of lives, I'm initializing. I could write this here. I could write this one here. This could easily come down here, and I could write m number of lives is equal to number of lives, but this is another way of doing it.
Okay, sir. Thank you.
Sure.